this episode, we take the segmentation mindset and apply it to the most obvious and most frequently attacked boundary in cloud environments: ingress, meaning inbound access. Ingress control is where you decide which sources are allowed to initiate connections to your resources, which destinations can be reached, and which types of traffic are permitted. Beginners often think ingress control is just blocking the internet, but most environments need some inbound connectivity, and the real skill is allowing only what is necessary while preventing everything else by default. When ingress is too open, attackers do not need clever tricks because they can simply reach what they want to probe. When ingress is too restrictive without planning, legitimate services break, and people create risky exceptions under pressure. Security groups, firewalls, and service-specific access policies are different tools for the same goal, making inbound pathways intentional, narrow, and auditable. Understanding how they differ and how they complement each other helps you build defenses that are practical, consistent, and resilient. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful way to frame ingress control is to think about the difference between being reachable and being usable. A resource can be reachable from the internet or from internal networks, and that reachability determines who can even attempt to interact with it. Usability then depends on higher-level authentication and application logic, but attackers often start with reachability because it lets them probe for weaknesses and misconfigurations. Beginners sometimes assume strong passwords or strong authentication will protect exposed services, but reducing reachability is a safer first step because it shrinks the number of opportunities attackers have. If a management interface is not reachable from the internet, then password guessing and exploitation attempts cannot even begin from that direction. Ingress control is therefore about reducing the attack surface, which is the set of entry points that can be attacked. When you treat reachability as a design choice rather than an accident, you become far less likely to expose sensitive services unintentionally. Security groups are one of the most common ingress control mechanisms in cloud environments, and they are best understood as rules attached to resources that determine what traffic is allowed. They often operate like a stateful firewall, meaning that when inbound traffic is permitted and a connection is established, return traffic is allowed automatically. Beginners sometimes confuse security groups with network routes, but routes decide where traffic can go, while security groups decide whether traffic is permitted to flow. Security groups usually evaluate rules based on source, destination, protocol, and port, which means you can allow only specific types of inbound connectivity. The power of security groups is that they can be precise and directly tied to a resource or a group of resources, so they fit naturally into segmentation design. The danger is that imprecise rules, such as allowing inbound traffic from anywhere on wide port ranges, can quietly defeat the benefits of segmentation. The mindset should be narrow by default, expanding only with clear justification. Firewalls in cloud environments often sit at different points in the network and can provide centralized control over ingress. While security groups are commonly applied close to the resource, firewalls may exist as network appliances or managed services that inspect traffic entering a network boundary. Beginners sometimes assume firewalls are only for on-premises networks, but cloud firewalls can offer strong benefits, such as consistent policy enforcement across many resources and deeper inspection capabilities. Firewalls may also support more complex rule sets, including filtering by destination categories, limiting traffic based on known malicious sources, or enforcing layered policies across zones. The key difference is that firewalls can act as choke points, controlling traffic as it enters a network or a segment, while security groups act like localized guards at each door. When used together, firewalls provide broad boundary protection and security groups provide fine-grained control near the workload. Understanding this layered approach prevents beginners from relying on a single control and assuming it covers every scenario. Service-specific access policies add another dimension to ingress control because not all inbound access is traditional network traffic. Many cloud services expose application programming interfaces, management endpoints, or data operations that do not look like simple port-based network connections. For these services, access is often governed by policies that define who can call the service and from where. Beginners sometimes focus only on network rules and forget that many cloud services can be accessed through provider-managed interfaces. A service-specific policy might restrict access to certain identities, require that requests come from specific network locations, or enforce conditions such as encryption requirements. These policies are especially important for services like object storage, managed databases, and messaging systems, where access often occurs through the provider's service layer rather than direct connectivity to a server you manage. When you rely only on network controls, you might miss these pathways. A mature ingress strategy includes network controls and service-level controls, aligned to the way each service actually works. A major beginner misunderstanding is believing that if something is inside a private subnet, ingress control is not needed. Private placement reduces internet reachability, but it does not eliminate inbound risk because inbound traffic can still come from other internal systems, from connected networks, or from compromised workloads. Internal ingress is still ingress, and lateral movement often happens through internal pathways. Security groups and firewall policies should therefore be designed not only for internet-facing boundaries, but also for east-west traffic between internal zones. If your application servers can reach your databases, that is necessary, but that access should be limited to the specific application components that require it. If a developer workstation network is connected, it should not have casual inbound access to sensitive services. Beginners should train themselves to think of every connection as a deliberate allowance, regardless of whether the source is external or internal. Ingress control is about trust boundaries, not simply about the internet. Another important concept is default deny, which is the principle that inbound access should be blocked unless explicitly allowed. Default deny sounds strict, but it is the normal foundation of safe network design because it prevents accidental openness. In cloud environments, default deny is often implemented by having no inbound rules unless they are needed. When you add rules, you should add them with specificity, such as limiting source ranges and ports, rather than granting wide access. Beginners often build rules by starting broad and narrowing later, but that approach frequently leaves environments exposed longer than intended. A safer habit is to start narrow, confirm the system works, and then expand only when you discover a legitimate need. This also improves documentation implicitly, because each rule tends to have a reason. Over time, networks designed with default deny are easier to audit and easier to troubleshoot, because the allowed paths are fewer and clearer. Ingress control becomes more challenging when you introduce shared entry points like load balancers, gateways, and proxies, because these components concentrate traffic and can simplify exposure management. A common pattern is to make the load balancer public while keeping backend services private, so only the load balancer can initiate inbound connections to those services. Beginners sometimes expose backend services directly because it seems convenient, but that expands the attack surface and makes policy harder to manage. When a single entry point is used, security groups can restrict backend services to accept traffic only from the entry point, not from the world. Firewalls can protect the entry point with additional inspection and consistent rules. Service-specific access policies can restrict what the backend services will accept even if traffic arrives. This layered design reduces risk because it creates multiple checks before a request reaches sensitive components. Concentrating ingress through controlled entry points is one of the most practical ways to reduce exposure without blocking legitimate business needs. Identity-based access intersects with ingress control in subtle but important ways. Even if network rules allow a connection, the service should still require authentication and authorization for meaningful actions. Beginners sometimes treat network controls as the only gate, but network controls should be one layer among several. The reason is that network controls can be misconfigured, and attackers can sometimes gain access from inside the network after compromising another system. When identity controls are strong, an attacker who reaches a service still faces additional barriers. This is especially important for service-specific access policies, where identity conditions can be enforced directly in the service, even if network reachability exists. A good mental model is that ingress control limits who can knock on the door, while identity controls determine who is allowed to enter and what they can do inside. When you build both layers carefully, you reduce the chance that a single mistake creates total exposure. Logging and monitoring are essential companions to ingress control because you need evidence about attempts, blocks, and successes. If a security group blocks traffic, that block can be a useful signal that someone is probing. If a firewall allows traffic that later turns out to be malicious, you want records that show what was allowed and why. If a service policy denies a request, you want that denial captured as part of the investigative trail. Beginners sometimes design rules, but forget that rules should be observable. Observability is not just for incidents. It is also for validating that your controls work as intended. If you change an ingress rule and suddenly see unexpected traffic attempts, that feedback can reveal exposure you did not realize existed. Over time, well-logged ingress controls help you refine policies and reduce noise, because you learn what normal inbound patterns look like. Managing exceptions is another area where beginners often struggle, because real environments always have edge cases. Sometimes a partner needs access, or a temporary test requires a broader allowance, or a troubleshooting session demands a short-lived opening. The risk is that temporary exceptions become permanent because people forget to remove them. A mature ingress strategy treats exceptions as deliberate, time-bounded decisions with clear ownership and review. Even if you are not implementing systems yourself, it helps to understand the goal. The environment should make it easy to do the secure thing and harder to leave dangerous exceptions lying around. When exceptions are tracked and revisited, the network does not slowly drift into openness. This connects back to earlier ideas about drift and baselines, because ingress policies are part of your baseline security posture. Beginners should see exception management as part of good operations, not as a bureaucratic hassle. Ingress control also needs to account for the fact that cloud environments evolve quickly, with new resources appearing and old ones changing roles. A rule that made sense when a system was a test server may become dangerous when that system is repurposed for something sensitive. This is why consistent patterns matter, such as always placing public entry points in known zones and always using known policy templates for inbound access. When the architecture is consistent, reviewing ingress becomes easier because you can spot deviations. When the architecture is inconsistent, every resource becomes a unique case, and unique cases are where mistakes hide. Beginners should understand that consistency is a security multiplier because it reduces cognitive load. If you can predict how ingress should look, you can detect when it does not. Controlling ingress with security groups, firewalls, and service-specific access policies is ultimately about turning inbound access into a controlled, minimal set of deliberate pathways. Security groups provide fine-grained, resource-focused rules that can enforce least access at the workload level. Firewalls provide centralized boundary control and can create choke points where inspection and uniform policy are easier to apply. Service-specific access policies cover the many cloud service pathways that are not just simple network ports, ensuring that identity and context conditions are enforced where the service itself operates. For new learners, the most important takeaway is that ingress control is not one tool, and it is not a one-time task. It is a layered design discipline that reduces attack surface, limits lateral movement opportunities, and produces evidence that supports investigation. When inbound pathways are narrow, intentional, and well-monitored, your cloud environment becomes harder to probe, harder to misuse, and far easier to defend with confidence.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.